Hey guys, good morning. This is Professor Nehru, Department of Aerospace Engineering. Today we are going to see the case study on the longboard simulation with Ansys software. So here we are going to see the case study, showcase how Ansys Mechanical within the Ansys Workbench interface can be used to find the ideal design of an longboard deck. So you can see the skating board which is shown in the slide. It is a demonstrates how simulation can be used to assess the deck structure, compare different materials like a bamboo stick, like aluminum plate or different carbon fibers. So and to evaluate the trade-off between the different designs. The problem statement is a longboard is a type of a skating board design for a downhill and salmon racing, but also used for simple crushing and the transport. So because it is a longer than a regular skating board and the normally has bigger wheel, it adds speed. So enhance speed. The increased weight and size makes them less suitable for many skating board trials. So to contribute to stability and improving the aerodynamic performance during the downhill movement. So here the geometry of the materials which we defined as three category. One is bamboo and the carbon glass fiber, also the plywood. So here in the preprocessor, the simulation setup to solve the longboard problem will be discussed in detail, which if you have having the new Ansys workbench or mechanical Ansys rated software, we can get it from the basic interface tool. The initial step, the bamboo was chosen as a material for the deck, while plastic TUP was selected for wheels and steel for the rest of the assembly. So here we have the modeling of the skating board and meshing of the skating board and loading condition. The tire will take the impact load and the skating board will act as a beam and will take the bending load. So here we have the modeling of bush with spring element and the mesh of the longboard, that is a skating. Here we have the solution method what we are using, the post process what we are getting, and what optimization value we are arrived. So the model has been solved using the ANSYS static structural solver. The output of the simulation can be seen in the figure. We have the different the total deformation as well as the stress distribution over the skating board. The high deformation is found in the board. However, the maximum value reaches it relatively low, which is 12.1 mm, and thus it not impact the use of the skating board. The high stress areas can be found as expected close to the bolts area and in the center of board where the load is applied. In the bold area, the stress reaches critical value and leading to factor of safety is greater than 1, that is less than 1, which means that the current design is not safe. So we have to modify and we have to upgrade the different materials where it has to be withstand more load and relatively the deformation should be very low and stress carrying capacity should be increased due to the various movements and the operation in downhill movements. So here in this case study, they done the trade-off analysis where they optimizing the thickness and the weight of the different boards. However, the question of the actual cost of each board design in terms of prices and environmental impact remain unknown. So in ANSYS Granta Edu Education Pack, in addition to engineering properties such as mechanical, thermal and electrical, are also present price and environmental impact information like carbon footprints. For the chosen material, this amount represents 0.5s USD per kg and 1.4 carbon dioxide kg per kg for plywood, 1.6 USD kgs and 1.1 carbon dioxide per the bamboo. So similar for the CFRP, we have 40 USD per kg, which is 48 carbon dioxide kg per kg. As observed, these values are defined per kg of material in order to obtain total values of each material. Design, they can be multiple by adding of weights, like weight, price and carbon footprints with different materials shown in the table, which will also help to the possible further analysis. It is important to mention that the analysis was performed with various assumption and simplification. For example, the metal property were taken as the bulk linear elastic, but often boards materials are laid and metal property can be an isotropic. By using the Ansys material design or synthesizing model in the Granta Edu Park, it is possible to simulate composite and layered metal structure and the bending as well as the loading capacity ensured in the accurate. This result, the point bend test, they are testing the skating board using applying the point load, and the further analysis they can also perform by considering topology optimization and investigated how to optimize all the longboard components. Lastly, by introducing the plastic and fracture properties into the material delaying as possible to model behavior of the deck at mechanical failure. In conclusion, in case study it was found so how ANSYS can be used to find the cheapest and lightest design of the longboard deck for different material. A simulation which together the parametric analysis was a setup using the static structural analysis model and model analysis. ANSYS workbench to compare different material takes from a previous material selection case study. Lastly, the trade-off analysis was performed to take into considering cost and environmental impact of the design choices and suggestions for further analysis were given. The ability to think that automated the different types of simulated drastically improved for flow and the speed of the design process, and ANSYS simulation reduced development optimization time by approximately 60% and cut design time by almost 50%. So this is a case study of skating board and testing with different material property in different load conditions. So thank you. We'll see you in the next class. Thank you.